Hi you guys, Merry Christmas. Sitting at piano lessons if you hear piano in the background. And we're going to talk about hydrocarbons. There are three types of hydrocarbons we're going to talk about: alkanes, alkenes, and alkynes. Alkanes is the first one we're going to talk about. And we've got four different parts that we're going to talk about with alkanes: straight chain, branch chain, naming, and properties. So straight chains. These are a couple of straight chain alkanes. This has one carbon, this one has two carbons, and around the rest of the carbon is hydrogen. We could keep going in a straight chain and add more carbons, and they would be different kinds. Notice that this is methane and this is ethane, and they are both alkanes, and there's a common trend here of A-N-E. This chart is showing you all one molecule, which is butane, and just different ways to write butane. Butane has four carbons. It's C4H10, that's its molecular formula. We could also write it like this. It's Lewis dot structure. We call that its complete. We could also write it as a condensed, showing each carbon with how many hydrogens it has around it. We could also write it in condensed and take out the bonds in between the carbons. And then here it's really condensed. They would put parentheses around however many of the same thing there are in a row and use a subscript. This one, it's still the exact same thing, and the hydrogens are still there. They just don't put them there because these hydrocarbons group together in big, huge, long, tangled arrangements, and it's just easier to visualize them if you leave the hydrogens, which aren't so important, off. This one even leaves the carbons off, and it's just showing you that there'd be a carbon at each point. And we can have branched chains, branches off that straight chain. And we call those branches substituents. The substituents we're going to talk about are alkyl groups. They're also made up of carbons. So here's a parent, what we call the parent chain. We'll get to that when we name them. This is propane. It's got 3 carbons, and it has 1 substituent carbon. Now keep in mind, these carbons would still have a hydrogen here, a hydrogen here, a hydrogen here. There'd be 3 hydrogens here, there'd be 1 here, and there'd be 3 on this guy. This one is hexane. Hexane has 6 carbons, and it has 3 substituents. Okay? Next, we're going to move on to naming. We need to name this and learn how to name these, and so there's a couple of different steps. In fact, there are 6 steps, so get ready to add that to your tree map somewhere. Step number 1 is you need to number the longest chain of carbons. Okay? So to determine that, you look at the chains, and it's possible that the chain could bend. Okay? So it could go like this, if that's the longest chain. Let's see. 1, 2, 3, 4, 5, 6. Nope. It's got to be a continuous chain. It could go like this. It could be a straight chain like this. Let's see there. 1, 2, 3, 4, 5, 6, 7. Okay, there's 7. So there's no other straight chains there. So we're going to number the longest chain. That's our first step. When we do that to number the chain, that's the first step. You find the longest chain and you number it. Now, how do we number it? Step 2 is you start with the end that gives the groups hanging off the lowest number. So lowest number 2 groups off chain. Okay, so that means I want to number them like this: 1, 2, 3, 4, 5, 6, 7. Okay, so since this is 7, I know that this is going to be, I look at this chart, 7, I have, you look at your number of carbons here, I have 7, so this is going to start with hept. And because this is the single bonded ones, all the single bonded ones end in ane. So this is going to be some, okay, we know it's some form of heptane. The next thing that we need to do step number 3 is to add numbers to the substituent groups. Anything hanging off is a substituent group. This is a substituent, this is a substituent, this is a substituent, okay? This one is on 2. This one is on 3. These are both methyls. They're methyl because they've got 1 carbon. This one is on 4, okay? It is F because it's got 2 carbons, so this is an F. All right? Now, so that means that we have a 2-meth and a 3-meth and a 4F. Okay? All right. Step number 4 is to add prefixes to substituents. Okay? So for instance, I have 2 methyls. So this is going to be dimeth. Okay. Step 4 was to add prefixes. We don't usually add mono. We don't add 1 to anything in chemistry pretty much. So we're going to write up step 5 and step 6 together. Step 5 is to alphabetize the alkyl groups. The alkyl groups, or what we call the substituents. And when we alphabetize, we ignore the dis and tris and monos and all that business. Step 6 is to use proper punctuation. So we need to name this. Okay, so last time I checked, Fe comes before meth. So we have, and we have to put the numbers in front of their groups. So 4 ethyl. Okay. And then you say 2, 3 dimethyl, and then heptane. And actually the heptane should just be written all as one word after dimethyl heptane, but I ran out of room there. And actually this, I meant to put this dash right here for ethyl, and that should be a comma right there. Right here. Should be a comma. So we've got 4-ethyl, 2,3-dimethyl heptane, and that is how you name. Next on the list are the properties of the alkane. Alkanes are nonpolar. That means that the electrons are equally spread, so we don't have them pulling one way or the other. So there's no definite negative or positive charge. That's our first one. They're nonpolar. They are a saturated compound. That means that the carbons are all of their bonds are filled up with something like another carbon, affected by weak van der Waals forces, which is something that we will talk about later when we get into intermolecular forces. But know that those are very weak forces, which means they're easy to break. Okay, so we're back to the three types. We've done alkanes, and now we're on to alkenes. We're going to talk about three things with alkenes: double bonds, naming, and they have one or more double bonds, and other bonds in there may be single. These are some alkenes. You'll notice that there's a double bond here, and there's a double bond here, and there's a double bond here. That automatically makes them alkenes. Notice I'm ending the name in "ene," alkenes. Notice that there are also single bonds, but the fact that there is even one double bond makes it an alkene. How do we name these guys? Well, here's a bunch of alkenes. This is ethene, this is propene, this is butene. Okay? When we name these, we name them almost exactly the same way as we name the alkanes, except they end in ene, E-N-E, and we start numbering them in the spot where the double bonds have the lowest number. So for instance, this is 1 butene because we number them 1, 2, 3, 4. If we started numbering down here, this would be 3 butene. We want the double bond to have the lowest number. Okay? And then this one is a good example of showing where the bonds are. So, excuse me, this is pentene, and there are two ways that you could number it. You could number it 1, 2, 3, 4, 5, or you can name it 1, 2, 3, 4, 5. Now, because we want the double bond to be in the lowest carbon possible, we go this way, 1, 2, so we can say 2 pentene, and then as we move along, there's a methyl group here, so it's 1, 2, 3, 4 methyl, so 4 methyl, 2 pentene. Unsaturated compounds. That means, unlike alkanes, these guys have a double bond. They don't have all their spaces bonded to something, some other atom. That's all that means. Okay, we're going to move on to alkynes. Alkynes. You'll notice the ending changed again to Y-N-E-S this time. We say it ines, alkynes. Alkynes have one or more triple bonds. Others can be single or double, but they have at least one triple. They are, oh, that's a little bit backwards. They're triple bonds. And this is an ethyne, okay? You'll notice that right here, there are 2 carbons with 3 bonds between it. That's the triple bond. Now this could be another carbon here instead of a hydrogen, and we could keep going, and there could even be a double bonded carbon to that after it, but with one triple bond, that changes that ending to "ine." These are also unsaturated because obviously they have some spots that don't have hydrogens where they have double bonding. So whenever there's triple bonding, wherever there's double or triple bonding, those are unsaturated compounds. These are not very plentiful in nature. You don't find them very often, where the other hydrocarbons, the alkanes and the alkenes, are very plentiful in nature. Alright, so that's hydrocarbons. That's it for you guys, except for, of course, you should be doing your saws daily. Make sure you get those done, get your tree map done, and have a good rest of your break.
Hooray!
Merry Christmas!
Hooray!